In your class 12 you will get amines there. Okay, so in the amines you can refer through this. So the question is asking you, it is not giving you a primary amine. Amine is your RNH2. RNH2, this is called as your primary amine. And when I will write like R2NH, it will be called as your secondary amine. And when I will write R3N, then it is your tertiary amine. But question is asking you which will not give you a primary amine. So the answer here will be this one, CH3NC. It is your isocyanide. Okay, this is your isocyanide. Now when isocyanide is there, when it will react with your LiAlH4, lithium aluminium hydrate. Now you have to know what is lithium aluminium hydrate. It is a reducing agent. It is a reducing agent. What is the work of a reducing agent? Itself they used to undergo what? Oxidation, but it will make the reactants undergo reduction. And reduction, that is the addition of hydrogen. So hydrogen will get added up. So nitrogen, here you can see clearly that with this carbon is attached, right? This carbon is attached. With this carbon is attached. But here with the carbon, what is attached? Nitrogen is attached. So immediately it will give you what type of amine here? Secondary amine. Secondary amine. So this will be the answer. Okay. Okay. So the second question is this one, match the following. You have the questions. Okay. So you can see here, coke is there, diamond is there, fullerene is there, and graphite is there. So you have to match this one. So coke is always used as a reducing agent. Okay. Coke is always used as a what? Reducing agent here. Diamond. Now diamond, fullerene is there, graphite is there. So graphite will be your carbon atoms. Okay, see, you don't have to look into all the following. Okay, like whenever you have to match something, you don't have to look into all the following options. Just you have to see option number, suppose the A, is it matching with 3 there in the options? You see, is it there or not? In the options, option number 3 and option number 4, the A has 3 or not? It is having 3 there. Okay, so we have to look into a different one then. Okay, diamond is there and your graphite is there. So graphite and diamond. So diamond will be a cage-like molecules. So B should be 4. Is B4 there? Okay, that is enough. That is enough for you. Okay, that will be enough for you. Then immediately you can find out the C is having 1 here, and D is having the 4th number, the D is having 2. Okay, so this is how you should match it up. Okay, match the following. So option number 1, you can see there, option number 1 is written there, both A and R are true, and R is the correct explanation of A. Option number 2 is written there, both A and R are true, but R is not the correct explanation of A here. Next, number 3 is written here, A is true but R is false. So number 4, A is false but R is true. So metallic sodium, when it is dissolved in liquid ammonia, giving a deep blue solution. Yes, this is correct. Next, the deep blue solution. The deep blue solution is due to the formation of amide. Okay, so deep blue solution is due to the formation of an amide. That is an incorrect one here. Okay, this is an incorrect one here. So clearly you can see that A is true but R is your false. So it will be option number C, or the third one, option number 3. Next question, in lecithinous extract of an organic compound. See the question, in lecithinous extract of an organic compound. Can you see there? So in lecithinous extract of an organic compound, both nitrogen and sulfur are present, which gives blood red color with Fe3 plus due to the formation of. So it is due to the formation of your FeSCN2 plus. Okay, it is due to the formation of Whenever less Igneous extract is there, so it is your always your Fe. With this Fe, it's a coordination compound. With your Fe, what is attached there? SCN. Okay, SCN is the ligand there. Okay, so Fe SCN 2 plus. So this will be the answer. That is option number 4. Option number 4. So this is a direct question. Okay, it's a direct question. Next, you can see a physical chemistry question is there. The conductivity of centimolar solution of KCl. Can you see the question? The conductivity of a centimolar solution of KCl. Is it there? Okay. The conductivity of centimolar solution of KCl at 25 degrees Celsius is 0.021 ohm inverse, centimeter inverse, and the resistance of the cell containing the solution at 25 degrees Celsius is 60 ohm. The value of the cell constant. You have to find the value of the cell constant. This is a question from your electrochemistry. Okay, electrochemistry in your class 12 again. Electrochemistry. So here they have given the conductivity. Conductivity is denoted by this symbol. It is known as kappa here. Okay, kappa. So kappa has been given here, and it is 0.0210. 0.0210. You don't have to write that 0. It's okay. 0.021. Up till here only you can write. And its unit is your ohm inverse, centimeter inverse. Ohm inverse, centimeter inverse. Centimeter inverse. Okay. So the kappa has been given, which is your conductivity here, and the resistance. And the resistance has been given as 60 ohm. 60 ohm here. So you have to find the cell constant. So how this is a relation with the cell constant? Cell constant is L by A. This is your cell constant. L by A, that is your length by area of cross section. Okay, length by area of cross section. Together it is called as your cell constant. So it is related in this way. Conductivity is equal to 1 by R into L by A. You have to find this L by A. So L by A is equal to conductivity into the R. So conductivity is there 0.021 and resistance is there, that is 60. Ultimately your answer will come here in centimeter inverse, and the answer will be your here in the option number 3. You can see 1.26 centimeter inverse. 1.26 centimeter inverse. Option number 3. Okay, option number 3. Let's see the next question. Again, assertion and reason question is there. So given below are the two statements. One is labeled as assertion A and the other is labeled as reason R. Assertion, they have said a reaction can have zero activation energy. Yes, definitely a reaction can have a zero activation energy. Next, the reason is given here. The minimum extra amount of energy absorbed by reactant molecules so that their energy becomes equal to threshold value is called activation energy. Yes, activation energy is the minimum energy required for a reaction to take place. Okay, so that is your activation energy. So that is also correct here, but how the options are there? Let's see how they have given the options. Option number 1 is given both A and R are true, and R is not the correct explanation of A. Next, both A and R are true and R is not the correct explanation of your A. And number 3, A is true but R is false. Option number 4, A is false and R is true. Here assertion is also correct, reason is also correct, but reason is not the explanation of the assertion. So it will be option number 2. Option number 2. Okay, option number 2. Next question. Which one is an example of heterogeneous catalyst? Can you see this question? Which one is an example of heterogeneous catalyst here? So number 1, it says oxidation of sulfur dioxide into sulfur trioxide in the presence of oxides of nitrogen. Okay. Next is your hydrolysis of sugar catalyzed by H plus ions. Next is your decomposition of ozone in the presence of nitrogen monoxide, and then combination between dinitrogen and dihydrogen to form ammonia in the presence of finely divided iron. Yes, that will be the answer, option number 4, because iron is a solid here. Okay, iron is what? It's a solid. Iron is a solid here, nitrogen is a gas here. So gas is giving you the solid here. Okay, the catalyst has been used as a solid here. In the presence, gas is also there. So gas is there, solid is there. So definitely it is a heterogeneous, definition of a heterogeneous catalyst here. Okay, heterogeneous catalyst. But if it would have been same, like gas is giving you gas, at that time it will be your homogeneous. Okay, understood? The others are the examples of your homogeneous one. So the answer will be number 4, heterogeneous. Next we will see again an organic chemistry question is there. Okay, so this is the question. So given compound, this is the given compound here. Here X means your halogen here. Okay, X is your halogens. That is a group number 17 elements. So the given compound is an example of, what? Benzylic halide. Option number 1 says benzylic halide. Option number 2 aryl halide. Option number 3 allylic halide, and option number 4 vinylic halide. This is your allylic halide. Okay, this will be called as your allylic halide. Allyl. This is your allyl. So it will be your allylic halide. Okay. Next, identify the product in the following reaction. Identify the product in the following reaction. That is also an organic chemistry question. You have that one? Can you see that question? Identify the product in the following reaction. So let's see the reaction. Okay, so you have to identify the compound here. Now you see this is your benzene diazonium chloride. See, this reaction is undergoing in 3 steps. Okay, so 3 different reactions are there. One is reacting with your copper bromide here in presence of your HBr. One is your magnesium with the dry ether, and one is with your water. Okay, so this is your benzene diazonium chloride. This is known as your benzene diazonium chloride. Now when benzene diazonium chloride reacts with your copper bromide in presence of your HBr, here you have to heat this up. So nitrogen will get eliminated out from here. H will react with the Br, and definitely it will make bromobenzene. Now this is your Sand-Meyer's reaction. Okay, this is your Sand-Meyer's reaction. In benzene diazonium chloride, there will be a chapter known as benzene diazonium chloride. That is a part of your amine only. Okay, amines part. So benzene diazonium chloride, you can find this one. You can find this question there. It is from your Sand-Meyer's reaction. So Sand-Meyer's reaction immediately says when benzene diazonium chloride is there in the presence of your copper bromide and HBr, it used to give you bromobenzene. Now this bromobenzene, it is reacting with what? Magnesium and dry ether. in the presence of dry ether. So magnesium will just get added up here. It is an addition reaction. Okay. So immediately it used to make MgBr. I think you have heard about this RMGX. RMGX, that is your Grignard reagent. Okay, that is your Grignard reagent. And there is a very specialty in Grignard reagent. That means whenever water is there, you just have to eliminate one thing here, MgOH and then X. And the X is your bromide here. The central atom's octet should be incomplete. Okay. And another condition is the central atom should have vacant d orbital. That means its d orbital will be vacant, that is 0 electrons. Okay, it should have a vacant d orbital. Any of these conditions satisfies, any of this condition will satisfy, then it will be your Lewis acid. Okay, so clearly here the answer is a BF3 here, BF3, because when you see boron, its valence electron is 3, boron's valence electron is 3, you can clearly see. Fluorine will donate 1 electrons, so its octet is incomplete. The central atom's octet is incomplete. Okay, so it is not having 8 electrons in the valence shell. This is the central atom. How many electrons? 6. Okay, so the answer will be BF3. So this will be your Lewis acid here, BF3. Okay. Again, we will see a question on organic chemistry. Okay, one question on organic chemistry. So here they have given a compound in this way. Okay, so this is the question, and here they have used, this is a compound, it is reacting with your zinc and mercury in presence of your concentrated HCl, concentrated HCl. It is giving you A plus water, 2 molecules of the water. Okay, so actually this question is related to your aldehydes and ketones. Okay, aldehydes and ketones. In your class 12 again you have got in your organic chemistry aldehydes and ketones here. So aldehydes and ketones, it says aldehydes or ketones, it can be an aldehyde also or it can be a ketone also. If I write R here and H here, then it will become an aldehyde, and if I write both R and R, then it is a ketone. So aldehydes and ketones, when it will react with your zinc and mercury in presence of your concentrated HCl. So this is a reducing agent. So reducing agent work is to give you hydrogen here. So remember, here the moles, whenever you are using a reducing agent itself, reducing agent, its work itself is what? Oxidation, but it will make the reactants undergo what? Reduction. Reduction means hydrogen will get added up. Okay, simple concept. So hydrogen will get added up here. Whenever you are writing hydrogens here, always remember that the moles that you will put here should be always even number. Okay, whatever the moles you will put here, it should be even number, or whatever the number you are putting, it is also known as the stoichiometric coefficient also. Okay, it should be an even number. So if I put an even number, the even number eventually starts with your 2 here. Okay, so definitely what will happen here? It will make water, H2O. But if I take out this water, H2O, there will be no hydrogens left here. Okay, so this time what we have to do? We have to increase the number of moles here. Okay, we have to increase the number of moles. That means the first we have used 2 here, that, and the next even number that we will put here is your 4. Now 2 of the hydrogen is gone, 2 of the hydrogen is gone, 2 of the hydrogen is still left, and this will get added up here and it will make the compound like this. That means it is giving you what? Alkane. And this is your Clemenson's reduction reaction. Clemenson reduction reaction. Okay, this is from your Clemenson's reduction reaction. This is a chemical property. This is a chemical property of aldehydes and ketones. So the answer here will be, you see O is there, this O will come out from here, just like what we have done from here. O, you can take out the O, you can take out the O. So that is why 2H2O is gone. Okay, why they have written here 2H2O? Because how many O are there? 2 oxygens are there. Simply because here 1 oxygen was there, that is why I have taken out only H2O. And now the compound will be, what will be the compound? It will look like this now. If I take out the oxygens, so this will be the compound. Okay, the compound A will be this one. So it is option number, if you look into the options, so it will be option number A, number 1, option number 1. Okay, option number 1.